to use it, you know the house, right? How to live in it. When somebody builds a house, what is the first thing they do?
They do planning.
They do a blueprinting.
Yes,
Right.
planning.
So, once you have a certain specification ready of what type of house you want, right, the first thing they talk about is, let's just do a architecture or a blueprint for that house. Okay. Same way for the software. Once you decide, hey, I need to build some sort of software, first thing you need to figure it out is, what kind of architecture I need to build software. Okay. So that's what we're going to talk about here. So essentially, when you look at the Wikipedia definition of architecture, specifically software architecture, it talks about it's a high-level structure of the system, okay, and the discipline of creating such structure, and the documentation of the structure. It's a set of a structure that needed to reason about the software system, talks about what element it contains it, and the relationship between them, okay? And the properties of both elements and relations, okay? So, for a moment, let's think about the house again, right? So if I needed it like 3-story house, right? The structure that they would expect it is different, right? So every house will have some sort of foundation, whether it's a 1-story, 2-story, or 3-story, right? But as you go ahead, once you build a foundation, for a 1-story building, the relationship of foundation with the frame that you build on top of it is defined less stringent, right? Because there's nothing else running on top of the first floor. But if you want to build it a building, then obviously the structure of the foundation needs to be different than what you do it in a simple 1-story house. Same way, as you build the software, depending on what you're trying to look for it, each of the component will look a little bit different, okay? And the relationship of how those are interacted. So one of the things they do it in the civil architecture, right, is they also identify as you build it, right, how much is the weight is going to come into this thing, right? So that particular bolt or a hinge that you build it is how much weight it needs to handle, right? That's nothing but a property of that particular component and interface that it's putting it into the other structure that's going to reside on it, right? Same way, we talked about the architecture on the computer side, right? That the relationship between an operating system and an application software, right? You need to know it, what is that relationship? Also, you need to know it, things like, hey, when I take it, certain picture, right? Take an example of the camera application on your phone, right? There is an expectation is how many seconds before all that work is done so that I can take the next picture, right? So when you look at it, sometimes it's 1 second, sometimes it fires off 10 times within a second to take that entire motion, right? Specifically when you're taking it a high-speed activity, right, and they're doing it. So those things define, right? Versus if I'm taking a simple picture by standing it, the expectation of how fast that will process compared with something which is moving object, it's completely different, right? So based on what my camera capability is done, that's why you see an awful lens, right? It comes on a digital camera, right? Because it allows you exposure at a different rate and that's processing speed, right? So those kind of things which interacts it, which is nothing but the relationship between the properties of the two elements, is important also in the software world. Okay. Now let's look at it, what are the types of architecture? Now, compared to civil engineering, right, the computer world is a lot more relatively new. Right? Humans have been doing civil engineering for over 5,000 years. They've been doing computer engineering for probably over a century now, not more than that, right? So, what you're going to see it in the architecture, just like it, when you look into the various eras in the human life, the architecture has evolved, right? From a Stone Age humans to now when you look at some really cutting edge architecture in today's world, right? Like Sydney Opera House and all those things. Okay. So all those reflect the changing need as it goes through it. And same behavior, you're gonna see it in the computer architecture, okay? So when originally the computers were built, right, and still in certain cases, you still need this kind of architecture, is monolithic application. Okay. In this type of architecture, all of your data that you're interacting in the computer system is coupled together only with the code in the same place. Okay, so there is, all of the things is a one single unit, both code. Okay, code is nothing but the instructions that you give computer to perform certain commands. Okay, so all of code, and the data is the data on which it operates, right? So we talked about simple one, right? So I give some input, I get some output, right? And I have some function that it performs. That's my basic construct of any computing system, right? Input, output. Now in this scenario, right, all of my data is enclosed with the code itself. So what it tells me is my input and function are closely tied. You're going to see this typically much more into a systems where all of the commands are kind of integrated within the system itself, right? So in the earlier days, right, when let me ask a question. Have you seen the movie Enigma? You've seen it, right?
Yeah.
It's the Second World War.
Yeah, machine
Code, right? So that's a perfect example of this, right? So essentially, I'll give some background so you can understand. In the Second World War, okay, German troops were using a encoding to communication going back and forth between the submarines, or what they call it is U-boats, to essentially sink all the supplies that were being sent from the US to the European countries, specifically all of the Allied countries, to do that, right? Those U-boats were sinking all those supplies, starving the European countries, specifically France and UK. So the problem that they solved it is essentially they built an encoding, decoding machine to decipher that messages which you send it, to figure it out what is the instruction being sent it, so that they can essentially go divert it around it. That entire thing was built it as a monolithic application, right? So essentially you get a message, right? Somebody puts in that message as part of the data, and then they'll start the machine, and then that entire thing will go churn it. Initially it will take like 28 hours, and they were changing on a daily basis. So then they had to figure it out to bring it down to 24 hours. That was still not good enough. They need to bring it down to 12 hours so that they can actually take an action against it after they get the message. So that's what the perfect example, right? It's a closed loop system. Another example is when you're sending it a rocket or all these autonomous satellite missions to the distant planets, right? Like Voyager, it's now crossed the galactic boundary or influence of the sun's sphere. Well, they need to operate on their own, because sometimes the data, right now it takes what, like radio signal takes like 38 hours to come back a round trip to the Voyager. You can't wait, like 38 hours, you don't even know what happened to that spacecraft. So all those systems are built using monolithic architecture, where your code and the data, or the ability to sense the data and operate it, is all integrated into one. These are kind of used more in a specialized systems, where it's tend to run in autonomous mode. Okay. That was the first initial architecture. As they evolved it, they figured it out, hey, my data piece could vary a lot of times. My code remains the same. Okay? But that there is a close relationship between data and code, so I still need to keep them together. But the input that I give it can be decoupled. So, in that scenario, the client-server architecture evolved, right? Where it gives you now ability to decouple your input entry away from your data in the code. Okay, so the banking systems, the mainframe system born, right? Where you go ahead to a terminal, what's known as a terminal, right? There used to be a big green dumb terminal. It's nothing but all you can do is type it and it will display the results. That's all. So that terminal, you give some input and create a request to your main computer system. They will process it, send you a response that will get displayed on the client screen. Okay. Modern day example, Google. Right? You go ahead, google.com, type in the input, what you want to search it. That request goes to Google servers. They compile the search results, send you back, it's displayed in your browser. Okay? That's a client-server architecture. Then they figured it out, hey, as the systems started evolving, you had more and more things happening, specifically in a banking system. Your account data is same irrespective of which branch you go in bank on. Right? So you will have an application access separated with the database for data systems, right? So that's where the database is involved. Oracles, SQLs, mainframe databases. Where all of your data is structured and stored in that. And your application essentially interacts with the database to get whatever the data they needed. So when you go to the bank terminal, right, or an ATM, you punch in your account number, right? At that point, it will go to the data and says, okay, who is this person? Is the credentials valid? What kind of operations they're allowed to do it? Right? So like it's if you have $100 in your account, you can go and withdraw $500, right? So that application here will rely on data here to figure out, hey, what do they have? And that rule will apply irrespective of which interface you go through it. Right? So there is an application here, and then there is a presentation here. Okay? So your application functionality performs whether you are trying to withdraw the money, deposit the money, or check the balance. Right? Now, if you go to the tailor at the bank branch, they will have a different interface, right? Because you're not interacting. They are like it's looking at their systems and telling you what your balance is. If you go yourself online, right, that's a different interface. But it still allows you to perform the same transactions or same functions. Or if you go to ATM and look at it, you can still do all those three operations, right? So all of your operations are similar based on certain data, but it's presented in different form. Okay. So as the need grew it went into 3-tier architecture. Then as computing became more and more common, there was a need to essentially evolve this into a multi-tier architecture. Okay. In this type of architecture, what you're going to see here is some commonality, right? So your database from the 3-tier architecture, right? The data tier still needs to be there, right? So when a computer gets shut down, you don't want your account balance to be wiped out, right? You still want it. So that's still going to be in the database. Okay. Now I'm going to do it on top of it is what is known as data access layer. So the example we talked about is Facebook, right? Let's talk another giant example, Amazon. Millions of customers, right? Logs in Black Friday, right? Comes in, logs in, there are tons and tons of people logged in at the same time, right? Well, this database, when you access it, it's usually in the millisecond, right? Which is 1 thousandths of a second. But when you millions of people log in and try to perform transactions, right? Specifically, if you're trying to do with a stock trading type of transactions, right? Where every nanosecond is important, right? Because the price fluctuates. You can't afford it to take everything from the memory. I'm sorry, from the database and process, right? Because it's 1,000 times slower. So you're going to keep certain component into the memory. You manipulate it, and as needed, you push it or pull in data from the database. So that becomes the data access layer, which stays in the memory, okay, of your process space. So you're going to start seeing it, things like unit of work, which essentially defines that, hey, when I'm performing a transfer transaction on an account, right, my unit of work is going to be all single thing. Take the money from this account, deposit in this account. Right? That's one single thing. If one component fails, so if I take the money and system fails, where did my money go, right? Preferably, you don't want a bank who doesn't think of it, that you take the money but don't deposit it, right? How many of you want to go and bank at that bank? Okay, so that's a unit of work that comes in, right? So that essentially performs what is known as the data integrity. That's what the data access layer does. Allows you to access the data and ensures the data integrity, irrespective of where it's stored. Because in certain cases, right, you can't do everything into one machine. It needs to scale out across multiple machines to do that, right? In Amazon, when you have millions of customers shopping it, you can't have everything go to one single machine, all the million customers. You're going to have a cluster of machines, and all the data eventually will go into the same database. Okay. Then on top of it, you're going to have what is known as a business layer. Okay. So that's where all of your business functionality and business services comes into. So if I'm performing a purchase transactions or a view transactions or order cancellation, order ship change type of things, right? All of those things are business functional. If I'm buying it from Amazon, right, depending on whether I'm a prime customer or I'm taking it a super saver type of thing, so it's going to ship it in 5 days versus 2 days, or if I'm doing it overnight shipping, all those things comes as a business. Okay, so my business functionality running on top of data functions. Okay, now the business itself, if you go back into here, right, that's where all of my business information was stored. It was still getting presented, right? But then I needed to know, hey, you know what? I'm building it one for a dumb terminal. I'm building one interface for ATM, and I'm building it one interface for online, right? Now that changes into, oh, I need to present certain piece of data, right? The device on which it is presented could be different. So that presentation layer is now broken down into two components. One is a presentation layer, and one is a user interface layer. Okay. So in the presentation layer, now it just talks about what is known as a model view controller. Right. So all it does is, what action is the user is requesting it, and based on a model, how should I present that? Like what kind of pieces of information needs it? It goes in and sends it to the user interface layer, which then decides that, okay, I have this data, how I'm going to present it. So a perfect example is when you use Facebook application, right, or your mail application. When you're using it on your phone, it's going to have a different look and feel presentation than when you're doing it on the laptop. Right? So, but it presents you exact same information, right? How many mails you got it, right? Just a different view, right? Whether you're going to display everything or you're going to just have a summary of 2 lines. That's the presentation in UI there. Okay. So now your systems is now broken down into multiple layers. Okay. The benefits of this kind of things, it now allows flexibility to scale things based on how you do it. Right? I have a single database, can expand it, high-speed processing for multiple millions of transactions. I can separate my business layer from a presentation layer. Right. I don't need to worry about what device customer will use it to look into the data. And then even in the data layer, now I'm kind of broken it down. The mobile devices can run on its own type of thing. All I have to worry about is presentation, and what is known as, nowadays is, called as an adaptive screen methodology. Okay, so your screen size is going to be continuously varying. Your software and presentation layer needs to support that adaptive screen. Right, so it doesn't matter whether you're using a 5-inch phone or whether you're using a 15-inch screen. Because now you can do everything from your phone. Same thing you can do it a lot of times from your TV, which could be 15 inches. A different flavor of multi-tier architecture then kind of evolved it into what is known as the service-oriented architecture. So, a lot of legacy systems, you're going to see it. When I say legacy system is, just remember, not companies don't write a new banking software or an ordering platform every day, whenever the platform changes, right? It's written once, and then as you adapt it and build a new software, you may just utilize a new technologies, right? So, this thing was typically in 90s, okay? So if you're going to see it interact with any application which is built in 90s or early 2000s, you're going to see this kind of behavior. If you go back and look into the systems which were built into 80s and early 90s, you're going to see a prettier applications. Okay. If you go look into the insurance industry or a lot of banking industry or government processing industries, you're going to see a lot of mainframe. You're going to see this kind of architecture. Okay, so depending on what type of systems you're interacting, you will probably go and interact with all the types of architecture. Okay. And as the internet took off, people started realizing that, hey, look, I not only need to build all the business only on my own terms, but now I need to go and interact with the other businesses, which is going to be, I'm going to depend on it, right? Take an example. If you go and try to buy something from online, it doesn't matter whether it's an Amazon or Walmart or whatever the online application is. Okay. You go buy it, you have to perform a payment, right? So that payment is going to happen through whatever the credit card you have it, right? Let's say you got a credit card from a bank A, right? So that bank A has all the information about your credit card, right? Amazon doesn't have it. Right? So when I go and say I want to purchase a book from Amazon, normally I'll go ahead and select the book, go into the shopping cart, right, and says I want to check it out. Prior to the internet world, when you were going into point of sale system, right? Let's say I was walking into Barnes & Noble to buy a book, like Barnes & Noble's most store. I'll go perform the payment, right? So they will have their own dedicated system. They have a way to figure it out that, hey, they may have a dedicated connectivity going into the banking systems, which allows it to say, hey, this is valid or not. Right? Before that, before the electronic payments, right, you have to give them a hard cash to do that, right? So the business was simple at that time, but now everything is online. So now anybody could be providing any bank's card, right? So it's not dedicated that, hey, I was using only Amex, or I was using only Visa, right? People use now PayPal, Apple Pay, Google Pay, all this different type of transactions. So now I need to figure it out is when a customer comes to purchase something from me and presents a payment method, I need to validate that payment method. Because without validate, I don't know whether that customer has the money to purchase the goods that I'm about to ship it to them, right? So I need to figure out a way that I can call whatever the bank that the person is presenting the payment form, to reach out to that bank and ask the simple question: is this customer a legitimate customer? Customer is trying to perform this kind of payment, and this is the amount. Will you be able to tell me that A, this is a valid payment, and two, whether the customer has that much balance, or you are willing to loan that customer that much balance for him or her to purchase this, right? So that means I need to, essentially, it's a service mentality, right? So I'll need to go and invoke that service, ask those questions, and get the response, and based on that response, I need to make a decision within my systems whether I'm going to allow them to purchase and complete it and then ship this product, or I'm going to go back and say, no, the payment method that you presented is invalid. I'm not going to let you purchase. I'm not going to let you move from a shopping cart into the shipping unit. Okay, is everybody with me? Right? So as it came in, that means I need to start building now services. What means is that now I have a lot more business opportunities open up that I can go and offer to a lot more customers, right? So one may look at it, hey, it's a complex, now I need to worry about finding the payment for everybody. Or the other person can look at it, now I have a tapping customer, which is not restricted only to come and walk in into my store, but anybody from Globe can go and order it, right? Or anybody within the geographical border of a country can order it. Okay? So in order to do that, I need to build a service layer, right, where I'm going to provide a payment service. Then I'm going to ship it either through the FedEx or UPS or US Postal Service. So I need that kind of layer services. Okay, so an architecture emerged which essentially provided support for those kind of systems. Presentation still the same, right? Comes to whoever is like ordering from their phone or a screen or going into some sort of online entry. Then I need to build an orchestration layer. Right? Earlier everything was within my own company systems. Now there's going to be dependency going out to the other systems, right? So now my purchase, which was earlier as simple as customer picking up things from a shelf, walking to the register and buying it, that has changed to it, where I'm going to allow customer to go view everything, whether I'm selling it or somebody else is selling it on my behalf. So if you go to Amazon today, everything that is kind of sold to you is not sold by Amazon. Some is sold by Amazon, some is sold by other companies under the Amazon's umbrella. Okay, so I need to first figure it out, a flow to say, okay, how I'm going to allow this customer to browse all that information. Then I need to figure out a way to purchase it, then to a ship, right? So there is going to be a business process that is tied in that I'm going to walk the customer through it to purchase it. Right? Same thing like it's if you do a purchase on Amazon, or if you now kind of go ahead and try to do your online banking function, it walks you through the step-by-step process, right? You're doing this, then you do this, then you do this, right? So the original flow of how human used to work it by walking into the physical structure to do the business, that has been now changed into the business process. All of the regulatory and all those aspects that you need to build it, because when you purchase it, well, you need to be collecting sales tax from that person. You need to figure it out based on where that item is going to be shipped at. Based on residency, you need to figure out what is the tax rate and do that, right? So there needs to be a specific orchestration of how things needs to happen from the business model. Underneath each one of them, you're going to have a service, right? So when I'm browsing for a book, I may have a service that says, okay, show me all the book product, right? So there's a service for that. Shipping, okay, tell me all the shipment options. 2 days, 3 days, 5 days, that becomes it, right? Payment, tell me, I'm doing this payment. Validate that for me, right? I want to ship it, validate the shipment tracking, right? Because as soon as you purchase it, as soon as they send it, they also send you a shipment tracking number that you can actually track the shipment. So all those services reside underneath that orchestration layer which calls. Okay. Now, underneath that service, you still need to have what is known as a components, right? So essentially your data, right? A customer is a customer, right? A payment is a payment. A product, whether it's a book, CD, DVD, is still a product, right? So I'll still need to worry about what are the underlying components that the services are using, right? So shipment essentially uses multiple components, right? What customer it needs to ship to it, what address it needs to ship to it, what is the carrier it needs to ship to, right? So there are multiple components that I'm using it within that service. Then comes the harder part, right? Great, I have those components, but my systems don't change every day. I still have systems that I built in 1970s. I've built systems in 1990s. And there may be some new systems that I just built last year, right? All these guys still need to interact with all those applications, which is exciting, right? So now I kind of decomposed all of my architecture into 5 different layers this way. So this thing you saw it was an implementation within a system, right? A single system. Now, this is an implementation of federated system, where I'm collecting data from a whole bunch of systems and presenting it as a single thing to my customer to do that business. See the difference between the two architectures? Right. So within even there, within one of the application, you can still see one of those previous architectures that we looked at. But as it evolves, this is where it's going to happen. Any questions on service agreement? It's important that you understand all this distinction, because as we go through the course, you will talk about how to essentially quality assurance all those components. And in a real life, you're going to end up interacting with all of these components as soon as you do. Then things changed, right? 2007 came and Mr. Steve Jobs decided to disrupt the whole industry, right? Started with the telecom industry, right? But the whole vision was disrupting everything. The smartphones came around. Did Steve Jobs invent the first ever smartphone? No. There used to be an HP machine, what we used to call a brick. Some of those who are that old knows that HP and Windows had a huge, very big phones, bricks, which will allow you to do only certain things, right? But with the smartphone, right, first with the Apple and then the Google, the whole thing of how people interact changed. That means they are accessing information which are not any longer guaranteed to be connected to the internet or connected systems, right? So if I look at structure here, right, you're sitting on your desktop trying to buy something from Amazon, right? You have an internet connections, right? From here, you go down, you have systems to system all connections. In this case also there is a dedicated connections going from each layer all the way to the bottom layer. As soon as you go to the mobile, that assurance is no longer there. The way the mobile industry works it is, as you travel it, right, there are a whole bunch of towers. Okay, so as you are moving it from one tower's range to another tower's range, typically the handoffs happen. Okay, sometimes that handoffs fail. Sometimes you don't have anything to hand off to. So if I'm like driving it through Western Plains, or I'm going through the mountain regions, there's no coverage in some areas for my mobile phones. When there is no coverage, and I'm in the middle of transactions, what happens? My transaction gets dropped, right? Because there's no more information coming. So I need to deal with those kind of issues. Or in some cases, it is okay for me to store and forward type of paradigm. Okay. So for example, all of you use a mail or SMS type of features on the phone, right? As you go through it, if you don't have a connection to the internet, through it Wi-Fi or 4G, right? You probably can still get the messages at that time, but not on your phone, right? It's stored into your Yahoo Mail account. You still keep getting the messages. Next time your phone connects to the internet, right? Now you open up your mailbox, right? It goes, tries to refresh it, right? So it tries to go and says, okay, whatever the action happened from the last time I'm connected to now I'm connected, give me all that delta. Okay? So you get the delta, and then you go end up again out of the network. But everything that was downloaded on the phone, you can still access it, right? You can still see what mail or what messages came through it. So now it's stored on your phone. What that means is now I need to define a structure where there is some storage also on your mobile phone, right? And that syncs with the master servers wherever those applications are. And then, right? So now I need to worry about two things, right? One is my connectivity being lost in between. So my servers here needs to adapt to that scenario that, hey, in the middle of the transaction, something might lose, I may lose that particular connectivity. So I need to essentially adapt to that behavior. Second thing, on my user interface side, I need to adapt the behavior that, hey, whenever I lose the connectivity, whatever I have it, I still have accessible through what is known as a local store. And then whenever I connect it, I need to know it, when was the last time this thing is, and I will sync it. Another thing that also happens is, when you are, like, it's not connected, you can still type in emails or messages, right? It'll store locally. So it's not just only information coming from this side to phone, but also going from here to there, and that server needs to update, right? Let's say if I deleted an email, oh, as soon as it syncs it up, I didn't want it to be deleted first. Okay. So mobile applications started building a different architecture now. It's still built on the all top of it, right? So all of your server components, it's still there, right? But the component that interacts now with the user interface now start needs to worry about it. And my user interface architecture for mobile phones, specifically the apps that I deploy on mobile phones, now need to start worrying about it. Okay. Any questions about the 6 architectures that we talked about? Okay. It's 10:10. Let's take a quick 10-15 minute break. Okay. And at 10:25 we'll start with the next segment, which is talks about the software development.